Good morning and welcome to Saturday of week 3 of your Physics 5 a day, and I hope you've had a good lie-in because it's time for diffraction gratings here this morning. If you wanted to find the wavelength of a laser, you could use the double slits practical that we saw yesterday, but it would be better to use a diffraction grating practical. And we're going to start here today comparing the two practicals because there are obviously a number of similarities, and that means it can be quite easy to mix them up. So in both cases, you shine a laser, or whatever your light source is, at something with a number of slits in it. The light diffracts through the slits, and this results in a number of coherent waves on the other side of the slit or grating. These coherent waves overlap and superpose in this gap, and that results in a pattern of maxima and minima on a screen some distance away from the slits. Okay, but what about the differences? Well, the most obvious difference is the number of slits. So in this case, obviously it's 2, but in the diffraction grating, you've got thousands of slits on something that's maybe sort of 3-4 centimetres across. And the next big difference is the size of the slits. So for the double slit experiment, the slit spacing, so that's the distance from the middle of one slit to the middle of the next slit, for double slits, that's about 0.5 millimetre. And remember, it's represented by the letter A in the formula. Now you're going to be able to see that. So if you hold up double slits, you will see the two narrow lines on it. But for a diffraction grating, there are so many slits and they're so narrow, you are instead told the number of slits per millimetre, and it's typically about 300 lines per millimetre. Now that gives you a distance from the centre of one slit to the centre of the next slit as something like 3 micrometres, so a lot thinner. And if you hold up a diffraction grating, it will just look dark. You won't be able to see the slits. They're very, very narrow. Okay, and the next big difference, because in this case you end up with 2 coherent waves overlapping, but in this one you end up with thousands of coherent waves overlapping, obviously you're going to get a different pattern on the screen. As we saw in yesterday's videos, the double slits give you an interference pattern that has maximum, minimum, maximum, minimum, maximum, minimum, maximum, minimum. So bright and dark fringes. But the whole pattern's probably only going to be sort of 3 centimetres across the whole thing. And the fringes themselves are probably about 1 millimetre from one to the next one. Whereas for diffraction gratings, if this is your central maximum, the next maximum is probably going to be a few metres away, and the same on the other side. So the bright fringes are still only sort of like 1 millimetre, just the same as here, but the gaps between them are much, much bigger. This whole pattern here is only maybe 3 centimetres across, but here the gap between one bright fringe and the next one is probably several metres. And this explains why the diffraction grating experiment will give you a much more accurate value for the wavelength than the double slits experiment does. The uncertainty in the slit spacing for this practical is going to be quite high. Even after you've averaged over at least 10 fringes, you're still going to end up with a percentage uncertainty of about 5%, and that's before you've added on the percentage uncertainties of all the other quantities that you've measured. In the diffraction grating practical, on the other hand, the distances you're measuring are very large, so typically at least 1 metre there and probably 2, maybe more metres here, and so the percentage uncertainty for these measurements and then your final measurement for the wavelength are going to be much lower. And then, of course, the different number of slits leads to a different formula. So this is the double slit formula for the wavelength, while this is the formula for the diffraction grating practical to give you lambda. And we'll look at this in more detail in the next video.